Yesterday I showed you my chocolate bars, and I started talking about the idea that mixed fractions and improper fractions can show the same thing. And then we started figuring out how we could convert mixed fractions into improper fractions and vice versa. But the thing was that in order to do it, we had to draw a picture every time. What if I don't want to draw a picture of my chocolate every time? What if I don't want to draw a picture of my fraction every time? Is there some other faster way to do it? Let's take a look at the chocolate bar I have and think about that. Maybe we can do it some other way. Here is my leftover chocolate, and as you can see, it's in mixed fraction form. I have 1 whole and 3/10. 1 and 3/10. How can I convert that into an improper fraction? Well, for an improper fraction, I need to know how many pieces there are in total. Well, how can I do that? The only thing I can think of is to start breaking up the chocolate, so I better get going on that. But this takes time. I didn't want to draw it as an improper fraction, because that takes time. But so does breaking up the chocolate into all these pieces. I wonder if there's a way to do this mathematically, rather than actually breaking up my object into so many pieces. Let's see if we can do this using multiplication. As I mentioned when we were looking at the table, the thing that we want to do when we're converting a mixed fraction to an improper fraction is count how many pieces there are. Now that would be easier if we actually have a picture of something. So for example, here's my chocolate pie. How many pieces are there when I've divided the pie into fourths? Let's count. 1, 2, 3, 4. So far, so easy. What about 2 chocolate pies? 1, 2, 3, 4, 5, 6, 7, 8. What about 3 chocolate pies? Well, I'm tired of counting. I think I can do something different instead. Instead of counting each piece, I can say, well, there are 3 pies, and each pie has 4 pieces. 3 groups of 4, 3 times 4 is 12. Well, that was much faster. I didn't have to count each piece. Multiplication sure is my friend. All right, what if I have 3 3/4 of a pie? Well, we just said that with 3 pies it was going to be 12 pieces, so 12 pieces for the 3 whole pies, and then we just need to add the extra bits. Well, the extra bits are 3/4, so how many pieces are there extra? 3. So there's 12 pieces from the whole pies, and then 3 extra pieces. 12 plus 3 is 15, so 15 pieces. I wonder if we can do that without looking at pictures. All we need to do is multiply in our head. So, how many halves are there in 1 pie?
2,
Right, because if we cut 1 pie in half, there would be 2 pieces. Okay, how many halves are in 2 pies?
4,
How many halves are in 3 pies?
6,
How many halves are in 17 pies?
34.
And how did you figure that out? Well, we know there are 2 halves in 1 pie, so 17 times 2 equals 34. Now, how many halves are there in 1½ pies? First, we want to start by counting how many halves are in the whole pies. Well, there's 1 pie with 2 parts, so that's 2. And then we count our extra bits. 1 extra bit, 2 plus 1 is 3. What if we had 2½ pies? Again, we count how many halves are in the whole pies. 2 pies, 2 halves each, so 4. Then we count the extra bit, plus 1 equals 5 halves. What if we had 3½ pies? Again, we're going to count how many halves are in the whole pies. 3 whole pies, 2 pieces each, so 6 pieces altogether, plus 1 extra bit. 6 plus 1 is 7. Okay, I think you get the idea now. What you have to do is multiply the number of halves by the whole number, and then add the extra bits. So I'm going to give you some time to do this in your head. press pause, then figure it out, and then press play to check your answers. Welcome back. Let's take a look at your answers. So in the first question, it says, how many halves are in 4 1/2? Well, how many halves are in 4? Well, that's 4 times 2 plus 1 extra half. 4 times 2 is 8, plus 1 is 9. Second question, how many halves are in 20? Well, first we multiply 20 by 2. 20 times 2 plus 1 more half. 20 times 2 is 40, plus 1 is 41. What if we're dealing with thirds? Well, I think you're starting to see a pattern now. A whole pie divided into thirds has 3 pieces. What if we have 2 pies? Well, then it's going to be 6 pieces. What if we have 3 pies? Then it's going to be 9 pieces. What are we doing? We're counting by 3s, which means we're multiplying by 3s. So when we're figuring out how many thirds are in a pie, we need to multiply the whole pies by 3. Let's give it a try. I want you to try it without pictures. Press pause to try and figure out the answers, then press play to check your work. First question, how many thirds are in 5 1/3? First we multiply 5 by 3, 5 times 3, and then add one more piece for the extra bit. 5 times 3 is 15, plus 1 is 16. Second question, how many thirds are there in 11 2/3? First we multiply 11 by 3, and then we add 2 extra bits. Why 2? Because there are 11 2/3, so we add 2 extra bits. 11 times 3 is 33. 33 plus 2, 33, 34, 35. What about fourths? Can we do fourths? All we need to do is multiply by 4. So press pause to try it, and then press play to check your answers. Let's check your answers. There are 3 wholes, 3 times 4, plus 1 more bit. So 3 times 4 is 12, plus 1 more bit is 13. How many fourths are in 10 3/4? Well, 10 times 4, right? Plus 3 more bits. Why 3 more bits? Because there are 3 fourths, so we need to add 3 more pieces. 10 times 4 is 40, plus 3 is 43. Now that we've done all of these brain exercises, I think we can finally learn how to convert mixed fractions into improper fractions just using multiplication and addition. How does it work? It's 2 steps. First step is multiply the denominator by the whole number. Why? Because what we're trying to do is figure out how many pieces are in the whole pies. So there are 3 pies, 4 pieces in each pie, 3 times 4. 3 times 4 is 12. Then what's the next step? The next step is to add that number to the numerator in the mixed fraction. Why? Because that numerator is telling us how many extra pieces there are. How many extra pieces are there? 1. 1 extra piece. 12 plus 1 is 13. Now what do you do with that 13? All you have to do is stick it back over the original denominator, because remember in the last lesson, we talked about the fact that improper fractions and mixed fractions will still have the same denominator. So 13 fourths. 3 1/4 is the same as 13 fourths. Let's try another example. In this case, we've got 2 3/4. So what's the first step? First step is multiply the denominator by the whole number. Why? Because what we're doing is figuring out how many pieces are in the wholes. Here's our wholes. There are 2 whole pies, and there are 4 pieces in each. 2 times 4, 8. And then what do? We add it to the number in the numerator. Why? Because the numerator is telling us how many extra pieces there are. In this case, there are 3 extra pieces. 8 plus 3 is 11. What do we do with that number? We know that an improper fraction has the same denominator as a mixed number, so we just take that 11 and stick it over the original denominator. 11 fourths. 2 and 3/4 is the same as 11 fourths. So, what are the two steps? Number 1, multiply the denominator by the whole number, and then number 2, add that to the digit in the numerator. Your turn. I'm giving you 4 mixed numbers, and your job is to convert them into improper fractions using the 2 steps that I just mentioned. Press pause to try it out. Press play to check your answers. Welcome back. Let's check your answers. First question in the top left, 3 and 1/7. So first step is to multiply the denominator by the whole number. 3 times 7 is 21. Then we need to add it to the numerator. 21 plus 1 is 22. So 22/7. Now the question in the top right, 5 and 1/6. First step, multiply the denominator by the whole number. 5 times 6 is 30. Then we need to add that amount to the number in the numerator. 30 plus 1 is 31. So 31/6. Question in the bottom left. 4 and 3/9. First step, multiply the denominator by the whole number. 4 times 9 is 36. Next step, add that to the number in the numerator. 36 plus 3 is 39. So 39/9. Final question, 7 and 5/8. Multiply the denominator by the whole number. 7 times 8 is 56. Then add that number to the numerator. 56 plus 5 is 61. So 61/8. And that's how we can use multiplication and addition to convert mixed numbers into improper fractions without ever having to draw another picture again. Using the magic of the internet, I have put the chocolate pieces back together, or at least the ones that I haven't eaten. And now we're going to figure out what the mixed number is and then convert it into an improper fraction. So I have one whole piece, so 1, and I have 3 parts. So the numerator is going to be 3. What's the denominator going to be? 2, 4, 6, 8, 10. So 1 and 3/10. Now how do I convert that into an improper fraction? First step, multiply the denominator by the whole number. The denominator is 10, the whole number is 1. So 10 times 1 is 10. And then we need to add that to the numerator. Numerator is 3. 10 plus 3 is 13. So 13/10. Well, I think I'm going to be running out of chocolate by tomorrow at the rate that I'm eating this. So what I want you to do today is, number 1, complete page 207 in your Jump Math book. Number 2, complete the online quiz. And number 3, leave me a classroom comment about what food I should be eating next for my fractions, because this chocolate's going to be gone.